Let's take a look at multiplication of algebraic expressions. Multiplications can be shown with a dot like b dot d, b times d, b bracket d, bracket bd, bracket b bracket d, or just as bd. Now the rule of sign says if you multiply two positives together or two negatives together, you get a positive result. Positive times a negative, or a negative times a positive, or a negative of a positive times a positive. In this case here, you're going to get a negative. In fact, if you take a look here, if you multiply an even number of negatives, you're going to get a positive. If you multiply an odd number of negatives, you're going to get a negative. In this case, we have an even number of negatives, so again, this is going to be positive. Now, the commutative law of multiplication states it doesn't matter what the order of multiplication is. If you multiply a times b, it's the same as b times a. And if we take a look at this example here, we've got 3y times minus 2x. We can multiply it directly, 3 times minus 2 to get our minus 6. Then we can multiply x times y and get this result quickly. We could also break it down into 3 times y times minus 2 times x. No matter how we do it, we're going to end up with the same result. Let's now look at multiplying monomials. We've looked at monomials before, and monomials are simply single-term expressions that have positive exponents. Let's see example 43 here and see what they're doing. They're taking this monomial times this monomial, and what they're doing is they're separating out the number part first, then they're separating out the a's and separating out the b's and then combining them. 4 times minus 3 is going to give us minus 12. If we look at the a's, it's a to the 3 times a, which is a to the 4th, b times b squared, which is b to the 3. So it's fairly easy once we write it out in this fashion to be able to come up with the answer. Let's take a look at example 45. What we have 3x squared times 2ax to the n. And again, let's separate it out as 3 and 2 and a and x squared and x to the n. If we do that, we're going to get 3 times 2 is 6. There's only one term of a, so that's a. Then if we remember our law of exponents, x squared times x to the n is x to the 2 plus n. And that, again, gives us our final answer. Now sometimes we're going to have a multinomial multiplied by a monomial. In this case, a is our monomial, and here's our multinomial here. And what you're going to do is it's going to be a times b plus a times c. And that is called the distributed law for multiplication. The product of a monomial and polynomial is equal to the sum of the products of the monomial and each term of the polynomial. If we look at example 46, what we have in the front is 2x. And what we're going to do is multiply 2x times each of the two terms. So it's going to be 2x times x, which is 2x squared. And then we're going to subtract 2x times 3x squared and get 6x cubed. And that is our answer. Let's take a look at example 47. This is a little bit more intricate, but let's take a look. We've got minus 3x cubed. So minus 3x cubed, minus 3 times 3 is minus 9. X cubed times x squared is x to the 5th. So minus 3x cubed times minus 2x is going to give us positive 6x to the 4th, x cubed times x. And then our last term here, though since it's minus 3 times 4, that's minus 12 x cubed, and that is our answer. Let's look at multiplying a multinomial by a multinomial. Let's look at example 48. So you have x plus 4 times x minus 3. So that means we multiply this by this to get x times x minus 3. Then we multiply 4 by this as well to get 4 times x minus 3. If we do that, we get x squared minus 3x, and then we get 4x minus 12. And when we combine the terms, we're going to get x squared plus x minus 12. Now there's another way to do this, and that's called using the FOIL method. That means first, outside, inside, and last. So we can basically skip this step here, if you want, by saying first, which is x times x squared. And then if we do outside, that's x times minus 3 to give us minus 3x. Then we do inside, which is 4 times x, and then we do the last terms, which is these, so 4 times minus 3 is minus 12, and again, we end up with the same result. Now, example 48 can be done in a vertical fashion as it says here. Now, if you take a look at a regular multiplication like 23 times 46, what you're going to do first is take this, multiply it by that. So we take the minus 3 here and multiply it by 4, we're going to have minus 12. And then the next step is to take this number 6 and multiply it by a 2. So this is going to be minus 3 times x, which is going to give us minus 3x minus 12. The next step is then to take this number and multiply it by here and multiply it by there. This is the same as taking x times 4 to generate the 4x and x times x to generate x squared. Once you have this, we can collect like terms. So x squared is by itself. We have 4x minus 3x, which is x, and then minus 12 by itself. And again, we get exactly the same answer as we had before. In example 51 here, we have 3 terms. And it doesn't matter what order we multiply them in, as we've seen before. So I'm going to start with the far right terms, which is x plus 1, and multiply that by 2x minus 3. And I'm going to use the FOIL rule. First is this, which is going to give us 2x squared. Outside, x times minus 3x is going to be minus 3x. Inside, 1 times that will be plus 2x. And finally, last, which will be minus 3. So when we do this, it's going to give us 2x squared minus x minus 3, which is what we can see here in this expanded term. The next thing we have to do is multiply this now times x minus 2. Now to finish this, we're going to multiply x by each term here. That's going to give us 2x cubed minus x squared minus 3x. And then is take minus 2 and multiply it by this, which is our minus 4x squared. Multiply this by minus x. Minus 2 times minus 1 is positive 2x. And then multiply this by minus 3, which is going to give us positive 6. After we've done this, all we have to do is collect like terms. Well, 2x cubed is by itself. We have minus x squared minus 4x squared, so that's minus 5x squared. Let's look at the x's. That's minus 3x plus 2x, that's minus x, finally plus 6, and that is our problem solved. Let's take a look at the product of the sum and difference of two terms. So if we want to multiply a minus b times a plus b, what we're going to do is use our FOIL rule. That means first, which is a times a, which is our a squared. Outside, which is a times b. And then inside, which is minus a times b. The last term, which is minus b times b, which is minus b squared. Now if we simplify that, that's simply going to be a squared plus ab minus b squared. So this is going to give us this difference of squares that we see here. That if we multiply a minus b times a plus b, we're going to get the first term squared minus the second term squared. Let's take a look at the product of two binomials having the same first term. So we take a look at x plus a times x plus b. Then we can use our FOIL rule to expand it out. So it's first, which is going to give us our x squared. Outside, which is going to give us bx. Inside, which is going to give us ax. And finally, our last term, which is ab. Now, if you try and simplify this, what you're going to get is x squared plus a plus b x plus ab. And that's exactly what we've got here. In example 54, we have again is first, which is w squared, outside, which is minus 4w, inside, which is positive 3w, which gives us a 3 minus 4w term here, and finally the outside, which is minus 12. So when you combine these terms, what you're going to get is w squared, 3 minus 4 is minus w, minus 12. Let's now look at the general quadratic trinomial. And as we can see here, this is a trinomial because it has 3 terms. So when we're finished with this, we're going to end up with 3 terms as well. So if we do this, this is first, which is acx squared, outside, which is axd, or adx. Then if we do inside, that's bcx here. Finally, the last term is going to be bd. Now if we take all that we've got and combine terms, that's going to be acx squared plus ad plus bc bracket x plus bd. And this is our generic quadratic trinomial. So here's an example where we're using exactly the same thing that we've got here, and we can expand this out here. This again is 3x times 2x, which is 6x squared. Then we have 3x times 5, which is 15, 6x squared. Outside is going to give us 15x. Inside is going to give us minus 4x. And the last term is going to give us minus 10. So this is going to be 6x squared. 15 minus 4 is 11x minus 10. And that is our answer. Let's now look at powers of multinomials. So if we take x minus 3 squared, we can then apply our FOIL rule. X times x is x squared. Outside, minus 3x. Inside, minus 3x. That gives us minus 6x. Minus 3 then times minus 3 is positive 9. And we're done. If we look at example 57, this is x minus 3 cubed. So what we have to do is use our FOIL rule here. When we use FOIL, we should be able to come up with this quite easily. Then we have to multiply x by every term, and then minus 3 by every term. So this is x times x squared is x cubed. X times minus 6 is minus 6x squared. X times 9 is plus 9x. That's the first part. Then we have to multiply minus 3 by all these terms. So minus 3 times x squared is minus 3x squared. Minus 3 times minus 6 is positive 18. And finally, minus 3 times 9 is minus 27. Now when we collect all terms, minus 6x squared minus 3x squared, so that's minus 9x squared. We have our x cubed in the front. We have plus 9x, 18x, that gives us 27x, and finally minus 27 to get our final answer. Now let's take a look at perfect square trinomials. What that means is we have something like a plus b all squared. So this gives us a plus b times a plus b, and again we can apply our FOIL rule. A times a is a squared. Outside is ba, inside is ab, same thing, and plus b squared. So that's why we get these terms here. Now if we collect those, this is going to be equal to a squared plus 2ab plus b squared. And that's exactly what they have here. Now we can also take a look at a minus b squared, which is what we have here. Now instead of a plus b squared, we can also look at a minus b squared. And instead of a squared plus b squared, which we had before, instead of plus 2ab, we just get minus 2ab.